Imagine you have two numbers. One number that can be defined and another number that can almost be defined. For example, you can have 3, 5, or 10. It can be 3 centimeters, 5 inches, or 10 yards. On the other side, you can have 6.1298, and the number goes on and on and on. That number never ends, actually. That number goes on forever. So can you really measure that number? It's immeasurable. It's irrational. You have rational numbers on one side and irrational numbers. And that's today's topic. Rational and irrational numbers. How it all began. Now, this story begins with a Greek guy, Pythagoras. He proposed a theory that any number can be written as a ratio of two whole numbers. This means a number such as 1.5 can be written as 3 over 2. 8 can be written as 8 over 1, because this is a whole number and this is a whole number. Next, when people asked him about complex numbers, such as numbers that would never end, let's say you had 0.1234, and on and on and on, and this number here doesn't end, actually. People asked him, what do we do with these numbers? How do we create these into these ratios you're talking about? And he said that there would be a mystery number that we would use to create them into these ratios. And people were like, okay, sure, I guess that kind of makes sense. And now, 100 years later, Greek guy Hippasus came to the picture. He said and proved with mathematical proof that there is no such number, and there never will be. Pythagoras' believers, students, they were upset. They weren't happy that he ruined their big picture. And they got so mad, in fact, that they even banished him from their town. And only 1,300 years later, people really started to deduce the difference and group them differently. For example, irrational numbers would go here, and rational ones would go here. They would know rational ones can be written as these ratios of two whole numbers, and irrational numbers cannot. Now, let's dive into some examples. Before we really start, let's identify what a rational number is. Let's make a list. A rational number can be any number that's an integer, basically any whole number, positive or negative. It can be a fraction, something over something, or it can be a decimal. But remember, if that decimal goes on or repeats, it must have a pattern. Now, let's do some practice. Number 1, 1/3, rational or not? Well, remember how the list said all fractions are rational. Anything that's something over something, something divided by something, it's rational. So 1/3 is rational. Number 2, 41. 41 is a whole number, an integer. So that number is rational. Pi. Pi can be written as 3.14159, and it goes on and on and on. That number is actually infinite. And I don't think we see any pattern among these numbers or the numbers that follow. So that number is irrational. Number 4, 13.777 repeating. This means that it's 13.7777777, and that 7 goes on and on and on and on and on, and that 7 is infinite. So it's 13.777, but the 7 goes on infinitely. That number would be irrational, but since it has a pattern, it's 7, remember? It's actually rational. Number 5, 21.6912, and there's more. This means that this number continues, and there is really no obvious pattern here. So I'm gonna mark this one as irrational. -63. -63 is a whole number, an integer. It's just that it's negative. But that still counts as being a whole number or an integer. So it's rational. Square root of 49. Now the square root of 49 is actually 7 because 7 times 7 is equal to 49. So we know 7 is a whole number and all whole numbers are rational. So square root of 49 will be rational. Number 8, 3.74 repeating. This would be written as 3.747474747474, and the 74 goes on infinitely. This number would be normally irrational, but since it has a pattern, it's actually rational. Number 9, square root of 50. Now, the square root of 50 is asking for what number times itself is equal to 50. Well, in that case, it's actually 7.07106, and it goes on, and there's so much more. So that number would really be irrational, because there doesn't seem to be any visible pattern here, or on the numbers that follow. Number 10, 2/7. Now, 2/7 can be written as, well, 2/7, which is a rational number because all fractions are rational. So 2/7 are rational. I hope you enjoyed today's lesson and see you next time.